In this lesson, we are going to look at, what are we looking at, y'all? I forgot just that fast. Oh, parent functions. All right, so we're going to take a sheet of notebook paper, and we are going to talk about all of the different non-linear graphs and functions. There are 6 of them, and we're also going to include our friend linear. Okay, so the first one is a linear function. And let's divide the paper 2 columns, 3 rows. The second type of function that we're going to look at is a quadratic function. And we're going to look at exponential, absolute value, square root, and cube root. And this should be a square root function. And this is cube root function. We're going to write what each one looks like on the graph and what it looks like as an equation. This linear function is y equals mx plus b. We all know that it is a straight line. If we shift this b, the graph will go up and down. So if the b is negative, it could be down here. This b is like at -2, and this b might be at 4. So understand what the plus on the end does, okay? The slope of the graph changes how it's slanted. So both of these are positive and the slopes are the same. All right, on a quadratic function, it is y equals x squared plus b. So a quadratic is a parabola. It graphs a parabola. And a parabola is a U-shaped graph. If this b changes, then it can go up and down. All right, so this one will be like y equals x squared minus 2, because that b is at -2. And that says that it graphs a parabola. Now notice that this one's a little bit wider, but it should be the same width of cross. If it's wider, that's going to be a fraction of a graph. So I'm going to say that this graph is probably actually y equals 1/2 x squared minus 2, because it's wider. Now all of this you can see when you put them in Desmos. graphing calculator. You go over to Desmos. Let me see if I can show you. All right, so these two functions, to compare them, this is a quadratic. All right, so here's Desmos. I'm going to type in y equals 1/2 x and then x squared minus 2. And then I'm also going to type in the parent function, which is y equals x squared. So you can see that this green graph is narrower than the red graph. The minus 2 in the equation is represented by that point, which is the y-intercept. Putting a fraction in front of it makes it wider. If I take the fraction off and I just put x squared, the graphs will be the same width, but I deleted the whole function. No, I didn't. Right here. I'm going to delete the 1/2 so you can see. So now it just shifted it up and down, which is why right here I said the plus b shifts the graph up and down. So let's go back. If this graph is, let's say this equation is y equals 3x plus 2, then this equation would be y equals 3x minus 2. And I can kind of show you that on the Desmos. So the first equation is y equals 3x plus 2. The second equation is y equals 3x minus 2. So it just shifts the graphs up and down. All right, let's move on to see what an exponential function looks like. All right, so we're going to draw a little coordinate plane here. And we're going to talk about exponential functions. The exponential function has an exponent in the function on the word exponent. They represent growth and decay, okay? So if something is growing or if something is decaying, you can represent it with an exponential function. An example of an exponential function is f of x equals b to the x. And that b, if it's growing, b will be greater than 1. If it's decaying, b will be less than 1 but more than 0. Not something that you really need to know, but an exponential function goes like this. Now, if the function, let's say like you have y equals 3 to the x minus 2 plus 1. This function, this is your b. And so what you need to know in regards to exponential is that it will shift the graph up, and this will be your y-intercept. I want to show you what this graph looks like. Exponential functions are curved, and the function itself has an exponent. They look like this, or like that. All right, the graph for it. Let's go to this one. Y equals, let's say 3, and the exponent, I press the A to the B button. The exponent is X, and then I come out of that, and I said plus 1. So there's the graph. All right, next part. All right, the next one. Absolute value. The letter is V. And that graph plots a V. Okay? The function itself will be like y equals the absolute value of x. If there's a shift, let's say that it's minus 2, then the y-intercept again shifts down to negative 2. All right, the last two functions are square root and cube roots, and those are curves. If you can remember quadratic, see like the u in quadratic tells you the shape of the graph. The v in absolute value tells you the shape of the graph. The e in exponent shows you how it's curved. Now, the last two are square root and cube root. The cube root function, we've talked about cube roots. Y'all have seen it in the last unit. Like if you have y equals the cube root of x, then the graph of that cube, oh, I'm sorry, this is a square root. Take that off. Let's say y equals the square root of x. The cube root function will be y equals the cube root of x. The square root function starts out, and it goes like that. You can almost see the square root symbol in the graph. It says, look, it starts here and it goes. Or you can say this, like there's the square root. Under the square root sign, you can see the graph. It's kind of like, look, square root. Okay? And again, if we shift it, plus b, it will just move up. On the cube root function, it's a little swervy. Swervy. And so it looks something like that. Cube root is swervy, okay? All right, I want you to familiarize yourself with these functions. We'll review them in the Desmos activity.